No way. And no way. I think it's the materials, the concepts. And then I noticed you guys working on it, I thought because it's 3 pages, many students finish up quickly. You did not. Some students worked until we left. Okay, so it's the material. And that material on logarithms, every semester. Every semester. Park and Anna probably recall that also. That's one of the roughest for students. Now the trait coming up is so different with this unit circle, you have to get accustomed to it. But thank goodness as an instructor, I think it's much easier to deal with conceptually than logs. Okay, we'll see what happens. Guys, any quick questions? Anything at all? Okay, now please, a little reminder, Ramsey does not know your grade. Campus does. So don't stop me on campus when you see me walk across campus. Professor, can I talk to you? I've had this to happen. What's my grade? I know your grade. What's your name? I don't even know. Come on now. Gee. Yeah, you're gonna have to go to campus. Campus has your grade. Okay, guys? So please, don't let that grade drop. Not with only a few more days left. Now, here's where I am. And I'm going to do a recap. My 11:30 session. We always have a good session. Okay. Here's what I got to do when I get all this organized. You'll get this. Just take a quick glance. We're going to get a copy of this. This is the last part of chapter 5. As if we just started. All of a sudden it's going to end today. Why? Because now they're saying, my goodness, students should know what sine is. Sine is y. I should know about the definition of cosine. Cosine is x. What does that look like graphed? Professor, these things have graphs. The log function had a graph. Exponentials have a graph. Quadratics have a graph. Parabolas. Straight lines, linear have a graph. Yeah, these have graphs. And here are the 6. Sine, cosine, tangent, cotangent, secant, cosecant. This is the way they look graphed. So how does this relate back to your unit circle? I don't see a circle on this. I don't see a circle on this when you get this. So how on earth did they take that circle and turn it into this? And call it now a graph, f of x, a function. And they do pass the vertical line test. So they are functions. Okay? I thought I saw a hand going up. Leo.
Oscillations.
What's that now?
The waves, like the oscillations, like if you're going around.
Oh, oscillations. Yeah, because I haven't even started this thing yet. They did somewhat, but I'm trying to show you how they take the unit circle that you should be accustomed to by now. And with Anna and Park's help, a little review there. You're going to take that. And what I call it to move into the graphing and finish up chapter 5 is they're going to unwrap it. They're going to take the unit circle and unwrap it. And then show how those graphs came about. But first, my 11:30 session. They're saying, Professor, we have a quiz on Friday. Not Friday, Wednesday. Yes, we do. And we have a knockout exam on Friday. We do. And do I have a review for you already for the exam? I'm just changing a few things for Friday. I've got the exam review. Do I have a review for the final ready? Yes. I'm working on it. I'm making a few changes. Wait till you see that review for the exam, final exam. And that's Thursday next week. I can't believe it's Thursday next week. And you have 3 hours. I do nothing that day but just pass out the test. And proctor, you have all 3 hours to take that test. Then you're done. Then I've got to quickly score those and get your scores into you as fast as I can, because now I'm working on my spring semester syllabus and closing down your class. We are busy. Okay, now you say, Professor, when I walk in here on Wednesday, I want to do well. What is happening here? Now, I may change, let me do this here. Let's find the exact value of these. Guys, watch carefully. I'm gonna lead you into it. And Jonathan, I'll ask you about that particular problem we were looking at 11:30 shortly here, okay? But let me lead into it first. Guys, here goes. Beautiful. You walk in here on Wednesday, things like this. And no unit circle to work with. First one, sine of 11 pi over 4. And I want a value. We'll come back to it. Put part B out here so I got space. The next one, in planning for today, I thought would be nice. Of course, here we go. Cosecant 17 pi over 6. Letter C. Cotangent 12 pi. And the last one, a little recap, of course. I have this, sine squared, 5 over 9, plus cosine squared, 5 over 9. So I want answers for all these. Got a beautiful recap for you before I jump into everything. Now guys, watch carefully. Here goes. You guys know the unit circle for the quiz also on Wednesday. The guys, first one says sine of, and it looks like it's 11 pi over 4. If you check out the unit circle, I don't think 11 pi over 4 is on there. But I see embedded within 11 pi over 4, which may give me a hint that maybe it has something to do with this one, which is on the unit circle. So it's got to take you back to the unit circle. So I can be taken back to the unit circle if I recall 11 pi over 4 has a reference of, there's a reference, a pi over 4. What I would do to make sure everything's correct, and I would divide 4 into like a fraction, 11 pi. And here it's just, as a fraction goes twice, looks like that's 8 pi, just doing math here guys, with the remainder of what, 3 pi. And looks like I could express, if I wish, and I do, I hope this orange, guys, you can see it, is 2 pi plus 3 pi over 4. That's another name for 11 pi over 4. Because I'm trying to locate it. And I think it was Parker who was interested in the quadrants. All students take calculus. So here, what I would do after the division, I would try to locate this. That's what you want to do. Well, first I'm going to move and show a 2 pi movement on the unit circle, which is one complete revolution. There's a little space there. That's 2 pi. But don't stop there. Move also, in addition to that, 3 pi over 4. Now you got to know your business. Now, if you want to think about 3 pi over 4 in degrees, that would be better for you. Convert it. It's 135 degrees. So I need to move an additional 135 from where I stopped in the blue. So guys, if I move this much, that's 90. Now I'm supposed to move 135, so I have to move an additional 45 and finally terminate in quadrant 2. Which is critical. Critical. Mr. Parker. So we're in quadrant 2. All students take calculus. Okay, that S you get, we're using that to remember everything here. S was for sine, right? All students take calculus. The sine definitely is positive, also is reciprocal, which is cosecant. So I'll have to remember that. And by the way, am I looking for sine? With that, all students take calculus. This right here is supposed to be positive. So I'm in quadrant 2. So I know the answer is going to be a positive. You don't place the positive sign there. I will just for a reference, it's positive. And now what is it? Well, the little reference angle right here. Along the x-axis. It's always along the x-axis. What size is that little reference angle, do you think? 45 degrees, which is pi over 4, which means yes, it should be. We saw embedded within the angle even before we did this. It's pi over 4, Professor, that's the reference. So this is like 45 degrees left over, which we prefer to write as pi over 4. That is this angle's reference. Now, I've seen your textbook do this, so don't be throwing it as you do your homework. They do this, they'll say, well, we're looking for sine of 11 pi over 4, which we are. That should be equivalent to, look at this guys, sine of pi over 4. Which I love. They should be the same. Everything's positive, I don't have to worry about sign change. Doesn't mean quadrant 2, and sine's supposed to be positive in quadrant 2. And therefore, sine of pi over 4 takes me right back to the unit circle. And the y coordinate of pi over 4, I think, remind me? 2. Radical 2 over what? 2. 2. And there's your final answer with all that thought. Gotta know your unit circle. Now that one's down with a lot of explanation there. As you do these, I know there's shortcuts. You do these in different ways. Next one says cosecant. Guys, to remind you, cosecant's definition, you gotta know your definitions, is 1 over y. Or 1 over sine, if you wish. 17 pi over 6, I'll make sure this was not on the unit circle, but I do see embedded within it is this. So it has something to do with, maybe that's the reference. 17 pi over 6. But where is the angle itself? Which quadrant? Because that's critical. Guys, I would sketch, but first let's divide 6 into 17 pi, just to see where I am. 2 pi, that's 12, doing basic math. Remainder of 5 pi plus 5 pi over 6. And there's 17 pi over 6. Which means if I want to sketch it, here we go. I have 2 pi, which is 1 complete revolution. Guys, that takes care of the 2 pi. Now it's supposed to move an additional 5 pi over 6. If degrees is better for you, 5 pi over 6 converted is 150. If that's better for you to move. So I got to move from there an additional 150 degrees, 5 pi over 6. That means here, that's 90. I've got to move 150? So I have to move an additional what? Is that 60? Yes or no?
Yeah.
Does it finally end up in quadrant 2 again like this one did? I didn't mean for that to happen, but it's in quadrant 2. And again, with Park's help, all students take calculus. He asks for students, asks for sine. Cosecant is reciprocal, are the only ones positive there. I'm looking for cosecant, and I guarantee the answer is positive. Yes. So I know the answer is going to be positive for sure. If you put the wrong sign on your answers on Wednesday or Friday, I got to take something off. Now what is it? I'm going to do a count here. We've moved an additional 150 degrees. What's left here? What's left for this angle right here, which is always along the x-axis? 30. Thank you. Call it pi over 6. And that's exactly what we thought it should be at the very beginning. I'm just giving you a why it's working. At this point, guys, cosecant of that could be expressed as
1 over 1 over 2.
Okay, let's see, it is. Okay, I got pi over 6, and pi over 6 has for coordinates, help me out. Now this takes me down into quadrant 2. And quadrant 2 should be, what, you guys, negative and positive? Got none of those coordinates? So could I, from the unit circle, write this for pi over 6 as negative radical 3 over 2, I'm squeezing down here, 1/2. Yes or no?
Yeah.
You gotta know all this. And then finally, maybe I can answer the question. The question says, get on with it and find the answer. It says cosecant should be 1 over y. Y is 1/2. If I have the numbers correct here, so it's 1 over 1/2, 1 over y, which simplifies into merely 2. And there's my answer. Let me go back and put the answer in. This one came up like this. Is this making sense? The way we connected. Okay, the next one says cotangent 12 pi. Oh boy. 12 pi is definitely not on that unit circle. Where is it? I would, no division needed here. No arithmetic, 12 pi, I know what's going to happen here. That's 2 pi. If I do it again, I'm not going to draw all these because you can see what repeats. This is 4 pi. And if I want to draw another one, this is, for a complete revolution, 6 pi. And I do that, and do that, and do that until I reach 12 pi. And I will finally land, if I did it more, right here again. And that point at the very beginning, the unit circle has for coordinates. Put that in this color so I can see it. Right here is what? 1, 0. Cotangents, definition, lots of things going on here. X over Y. And if I place the X over the Y, if I have everything correct here, I would be placing 1 over 0. Which is what?
No solution.
Undivided. Some textbooks will say D and E does not exist. Undivided. Now, is this helping?
Yeah.
Gee, okay. Last one is obvious. I'm not gonna sketch pi over 9. In fact, pi over 9, I don't know much about pi over 9.
20 degrees.
Yeah, sine squared plus cosine squared from last week is always equal to 1. It's one of the trig identities. So you just automatically say, Professor, my goodness, there's no work to this one. I agree. It's 1. So you have to know your identities.
And for given a question like that, it's acceptable just to write 1.
Absolutely, write 1.
Right.
Now, don't do this. I got pi over 9. The answer for this one's 1. And for some reason, you'll say, Professor must have messed up because he wrote this as pi over 5. Must have had a bad day, Professor wrote this thing down wrong. And the answer's 1? Nope. Nope. Why can I not say automatically it's 1?
Because they're not the same.
They're not the same angle. It says sine squared theta plus cosine squared theta again. The angles must match up. So pi over 9, not pi over 9, pi over 5. Cannot say that. That is not equal to 1. Yeah, Leo.
How would you solve it if it was pi over?
Beautiful. Woo! I'm trying, let me convert pi over 9 real quickly into degrees. Does anyone know what pi over 9 is in degrees? 20. Is 20 degrees? It's 20 degrees. I know nothing about 20 degrees myself. Nor do I want to. I know nothing about 20 degrees. If it was just bumped up a little bit, for rocket to 30, I know all kinds of things about 30. Or 45, or 60, or 90. 20? My 2 TAs. Mr. Parker, you know anything about 20 degrees?
No.
No, we don't. Does it exist? It sure does exist. Except I just don't know anything about it. So I couldn't deal with it. Could not deal with it. Who asked that? Leo, was that you? Yeah, I couldn't deal with it. Unless, oh boy, I changed back to 9 here. I do know this though, it is 20 degrees, which is awkward. But if it says sine squared plus cosine squared, I don't care what it is, as long as they match up. It's 1. Sine squared pi over 9 plus cosine squared pi over 9. Automatically, no thought to it, it's gonna be 1. Okay? Yeah.
Follow. So sine squared pi over 5 plus cosine squared pi over 5 is also 1.
There, look at that, that's what I want to hear. Look at that. Now you say, oh, Professor Schwartz, looks like that now. Now the answer's 1. And you know, I have no clue what pi over 5 or pi over 9 does, nor do I care. But sine squared pi over 5 plus cosine squared pi over 5, automatically 1. Yeah.
So for B, which was cosecant 17 pi over 6, you're using division to determine
Which
the
quadrant?
rotation
Which
of
quadrant?
this. Okay, got
Which
it.
quadrant?
So that, okay, that makes sense to me.
Which quadrant?
Yeah,
And then that quadrant will more than likely have what sign to it, affixed to it.
got it.
Okay, for an answer. All kinds of little things playing here. And it looks like, John, before I get to that beautiful question here, in fact, I might be ready for it. Guys, this morning, my students who joined me at 11:30, they bring in some really good questions here. Jonathan,
Yep.
remind me what it was, because it was a knockout.
Yeah.
Here we go.
So 2 sine 5 pi over 4 plus 3 cosine pi over 2 minus 4 tangent 7 pi over 6.
That is beautiful. That would be like a quiz ball. Now, what we did this morning, you guys were with me this morning, can sort of help me out, need some help here. First, here we go, I'm gonna try to determine in that first term, I need sine of, and I know what sine is, sine is y, at 5 pi over 4. Now, I think 5 pi over 4 is on the unit circle. And if you convert it to degrees, I think it's 225 degrees, so that would help. So if I sketch real quickly, just to see where it is, that's all I'm doing, you see where it is. 5 pi over 4 is down in quadrant what, guys? 3. And if I'm down in quadrant 3, all students take calculus. Tan and cotan are the only two positive ones. A quadrant pair, though, it's got to be down here, what? Negative, negative.
Yeah.
Now, since it's on the unit circle, you probably know the numbers associated with those. And I think it came out to be for 5 over 4 was a negative radical 2 over 2.
Yeah.
And another negative radical 2 over 2. All this thinking. That's what it is. Now, I might be able to answer the question now. So what's the sign, the y? Well, the y is negative. I'll put it right here. Negative radical 2 over 2. That's just the first term. And we're not quite finished with it yet. I'll go ahead and see what happens here. Guys, out front says 2 times that. Orange. Well, the 2's will cancel. And leave me all together for the first term. I gotta find some space up here. We'll put to the top, guys, and try a different color here. See if this black will work out. The first term after all that business comes out to be that. That's the start. That's term 1. And the way it looks, that looks like there should be just a quiz there. First, you tell me there's more? Yeah, there's more. Now you gotta add to this. Now look at this. Pi over 2, if I sketch it, I know where pi over 2 is, that's 90 degrees. And I do my sketch counterclockwise. I'm here, ordered pair if I need it, which I might need, 0, 1. No reference angle. I'm right on the y-axis, 0, 1. I'm looking for cosine. Cosine's definition is x. Look at all this work required. So cosine at pi over 2, the x-coordinate at pi over 2 is 0. That's cosine. And then I had out front 3 times that, which is not going to change anything. So my next term is 3 times 0, which is 0. Now I'm down to my last term. Last term says find tan of 7 pi over 6. And guys, I think 7 pi over 6 is on there on the unit circle. Please remind me if you make a sketch for 7 pi over 6, is it in quadrant 3? Please make sure I'm in the right quadrant. Is it? And it's one of those where I see embedded within it, which might help always, pi over 6. So it must have something to do with pi over 6, like its reference. The guide pi over 6 was for coordinates, radical 3 over 2, the basic one, and what, 1/2? Since I'm down in quadrant 3, my sign should be, there you go. So now I'm going to end up with, for tan of, I need y over x, and these turn into negatives. Since I'm in quadrant 3. And then tan of this, tan is y over x. Look at all the business going on here. And what I'm going to do, look at this, you're going to write y, negative 1/2, over x from those coordinates. 2's cancel, so we have a positive answer, and rationalize, I will do it quickly, it finally looks like that. For tangent, y over x. And then I'm not quite finished, it says now 4 times that, which is going to be awkward as you know what, but 4 times that, I'll put it up here in the black.
4 radical 3 over 3.
There you go, it's going to be 4 radical 3 over 3. Wow. And there is now here, those are the answers for the 3 terms. And my students this morning were asking, Professor, I see the black, you're saying this is it. This is it. But I think we went ahead and put those together with the common denominator of 3, didn't we?
Yeah.
And wrote that answer as some crazy thing like, with the common denominator of 3, guys, I think it's a negative 3 radical 2
Yeah, minus 4.
minus 4 radical 3. Look at this crazy one. Answer here. All over 3. Welcome to pre-calc. That's the final answer. Okay? You got to put all these little pieces together. Now I guarantee you, pi over 6, pi over 4, and pi over 3 are going to be used over and over and over and over. But you have to be very careful which quadrant are you in. Because the sign varies. Yes?
Would we leave it at that negative 3 root 2 minus 4 root 3?
Yeah, Leo, I can't do anything else with it unless I turn to a calculator with a square root key. No, I can't do anything else with it. I just leave it like that. Now, I know if I were taking a quiz and I saw that come out as an answer, I'd be very hesitant to leave it. I'll keep checking my work and checking my work. What a strange answer, Professor. And all of a sudden, you say, well, I've done all I can do with it. This was it. Strange answer. That's all I can do with it. Now, how's that look, guys? So by Wednesday, for sure, you gotta know the y over x, the x over y, the 1 over x, and all that business, and which quadrant are you in, and the reference angles associated with these things, and so forth and so on. Now, before I leave it, Jonathan, I think you were concerned about this. Let me call it letter F. We did not do it this morning, but here we go. The best I can do, if I did this, is I ask you for the cosine. Here goes, I'm gonna make one up here. Hang on, but I'm standing trying to create one. Yeah, let's do this. I'm doing it in degrees, rather than radians. Cosine 170. I'm doing it in degrees. I don't think 170 is on that handout. I think 180 is. I don't think 170. Okay? You said, Professor, what can I do with it? You can't do anything with it unless you had a calculator. Unless you had a calculator, you can finally get an answer. We're not gonna be able to get an answer here. What I can do though is through this, I can sketch 170. I have this one in degrees. And 170, guys, will finally terminate over in quadrant 2. That's 170. Close to 180. Now, can anyone tell me the size of that little angle left over hanging on along the x-axis? That's its reference. 10 degrees. Mr. Park, you're going to check something for me here just shortly. This is 10 degrees. That is 170's reference.
So it'd be the same as
Let's
negative.
write it all out here. I'm asking for a cosine. Now keep in mind, I'm in quadrant 2. It's cosine, which is x. And I know from across the street from middle school, if you plot a point, I think it's negative positive here. If you're in quadrant 2, and cosine is x, so x must be negative. So I know the answer is going to be negative. Cosine is x, and x is negative in quadrant 2. Now the best I can say here is, and I think, Eric, you're telling me what to do here. What is it?
Negative cosine of 10 degrees.
Yeah, beautiful. Beautiful. That's what cosine 170 looks like. It's negative cosine 10. Now, do I know 170? I don't. Do I know 10 degrees? No. That's the way it's written. Mr. Parker, do me a quick check here. Would you first find, you have to use a calculator or something, find cosine 170 for me. Just directly 170 in degrees.
Negative 0 point
Wait, negative 0 point something?
98.
98? Now, find cosine 10 degrees. How about a negative sign in front of it? What's cosine 10 degrees?
0.98.
They're the same. They are the same. I can't do anything else with it. I could express cosine 170 like that. You go. Leo.
Does this unit test us more on like knowing how to do things rather than knowing how to solve, or a mix of both?
Well, no mix. Well, we haven't started solving equations yet, but you see a trig equation. Well, you see a quadratic with a trig function. I have to use quadratic formula or factor. It's got trig in it. What's going on? Guys, any concerns here? So basically, I think with that little recap, took a little chunk of my time here, I think it's well worth it. Just to get your mind back on, I've got to know the unit circle. And professor, if it's not on the unit circle, I better do what you suggest, and that is divide this thing out. Let's see where it is. Now, if it does not lead you to pi over 6, pi over 4, or pi over 3, or one of those basic ones, 0, pi over 2, pi, 3, pi over 2, 2 pi, you've done something wrong. Because mine will be, I use the word rigged, but on the quiz or exam, I want you to make sure you go back to the unit circle. You're not gonna go back to 10 degrees. You always go back to one of those that you do something about. Making sense? Okay. Look at it closely. I think we did a good job, especially my 2 TAs coming up giving you some shortcuts on how to memorize that unit circle. Yeah.
Could we also, like, without a calculator, because we know that cosine is close to 80 degrees, say that it's relatively close to
Look at
1?
that. Since it's
Or
so
negative
close, I know
0.
cosine down here, guys. If I should, for 3. If I should reach 180, I think that point was what, negative 10 on the unit circle? Right at 180? Wasn't it, negative 10?
Yeah.
So he says, professor, since 170 is so close, I bet the answer must be close to negative 1. For cosine, right? I think I was doing cosine? Yeah, cosine's the x. So it's the x for the 180, negative 1. I got 170. So it should be maybe close to negative 1. Eric, is that what you're thinking?
Yeah.
Absolutely. Good thinking. Wow. Are you guys gonna make it? Gee. Anna, Mark, what are you guys doing over the weekends?
Calc
Well,
2.
We're gonna have to
I was
extend.
in Calc 2.
I know, she's very good in Calc 2.
I wish.
Going to a weekend here. Okay, guys, all this is done. Now you say, okay, professor, I sort of get a feel for what's going on here. I got a lot to memorize, and I gotta know what I'm doing here. Let's see if I'm ready. Oops, I'm not ready. Let's jump into some graphing. Part 2. Now, if you're taking this class or getting ready to take a calc class at the university, they always give a test. Most of them do. They give a diagnostic test. Just for your sake, they'll say, you did not perform very well in this diagnostic, so we might suggest you're not ready. But all of a sudden, somebody say, no, I'm just stick it out and see what I can do. That's just a little diagnostic to see how strong you are in certain topics. I saw something like this. They gave this information. Tan theta is equal to, and in fact, your textbook does some of this, and you'll be responsible for this type. Also on a quiz or an exam. Tan is that, and, what a beautiful follow-up question here. And cosine of theta is this. Okay, tan is -3. Given to me. And cosine, they did not give me a value, but they say it's positive. They want you to find, with that information, looks like, let's see if I'm right here. Oh, sure enough. The values of the missing trig functions. How many trig functions are there altogether?
6.
6, they gave me 1. Now they're asking you to find the other 5.
We know cotangent is.
Oh, hang on, just a second. And if I were, and I'm gonna ask Eric to help me, they're saying find sine theta value, I will. Find cosine theta value, I will. Find secant, I will. Find cosecant, beautiful. Problem. And number 5, find cotangent. These are the missing ones. I had no mistake up here. They give me 10. Now you tell me. Eric's telling me real quick, he says, Professor, I see 1 for sure. 1 answer for sure. Eric, tell me which one it is and tell the rationale, because I'll be asking for the rationale.
Oh, well, we know that cotangent is -1/3 because
Hang
it's the
on.
reciprocal of tangent.
Right here?
Yeah, it just has to be the
You're saying
reciprocal.
cotangent theta somehow can be expressed as 1/10. I see that. Is that true statement? Is 1/10 the same as cotangent? If it is, it says it's a reciprocal. So if they gave me tangent, then automatically he's gonna tell me the answer here is, Eric, what?
-1/3.
Beautiful.
And then from here, we can also tell that it's in quadrant 2 because you have a negative tangent and a positive cosine.
Love it, love it, love it. He says, Professor, better go back and locate this angle. What angle are they talking about in the given? Well, they're saying tan is negative, and tan, guys, is negative in which quadrants here? Help me out, quadrant 2? And quadrant how much? 4. Are those the 2 quadrants where y over x in basic algebra is negative? I know they gave me a -3, but it's negative. Now also they said make cosine positive. Well, cosine is x. Where is the x positive? Quadrant 1 and what else? Quadrant 4. Are those the only 2 quadrants where x is positive? Which is cosine? Is that true? You gotta know all this. Now where do they match up? That's where I'm located. This information takes me to quadrant 4. That's where both are true. Okay, so I'm in quadrant 4. If you want to sketch it, go for it. I know it's in quadrant 4 somewhere. Sketch is not really needed, but here's the angle down here in quadrant 4. And I know if I'm in quadrant 4 from across the street, it's positive, negative. All kinds of thought here. Now, Eric, thank you so much. We found cotangent easily because of the reciprocal of tan. So since you gave me tan, I just flipped it over. Now, does anyone think they know, because I got what, 3 more? No, 4 more. 4 more left.
Is sine theta just -3?
Oh, I wish. I know exactly, that's why I brought this in. I know exactly what you're thinking. Why would you say sine is -3, Eric?
Well, just because we know that tangent is y over x.
Okay,
And its
beautiful.
reciprocal is x over y, which is -1/3 and -3. And
Okay.
so if y is -3, then, or like, the fraction can be rewritten as -3/1.
Hang on, I'm with you. Take this thought. No problem there, that can be written like that.
And then you can set
Hang
it
on now.
equal to x over
So
y.
you're saying this is y over x,
Or y over x, sorry.
right? That's what tan is. And then all of a sudden you say, wait now, Professor, y is sine, so sine must be -3. And x is cosine, therefore cosine must be 1. And therefore you start filling your values here and jump down here, and with his help here, I'm where I am, oh, you put sine to be a -3 here,
But it's not.
and this would be 1,
But it can't.
and it's not.
Yeah.
Anyone give me a rationale why? Oh, Eric, I would have done the same thing as a student. Makes all kinds of sense. Y over x, Professor, y is sine, x is cosine, don't you? Sine is -3, cosine is 1. Anyone give me a reason why that might not be possible in this case?
Well, they have to be less than,
Just wanna lead me into my graphic shortly.
sine and cosine have to be less than 1.
Yeah, how high up does sine go on the unit circle? I don't have the unit circle drawn in front of me. Yeah, at the highest point here, guys, for y, that's y, sine. Is that the highest point, 1? Is that the highest you go for sine, is that 1?
So then.
And how, lowest is what, -1? So I can get down to a -3. Now for the unit circle, I can't do it, sine, it doesn't exist. Mr. Park,
Mm-hmm.
do me a favor.
Mm-hmm.
We're going to use an inverse key, I'll do this later. Do an inverse, because I've got to try to find this. Do inverse tan -3 to see what the calculator, oh no, inverse sine -3. Inverse sine -3 and see if an angle pops up.
Undefined.
Of course, it's undefined. Now, Eric's telling me though, he said, Professor, I forgot, it can't be -3. If sine, which is y is always caught between what and what? 1 and -1.
So we.
Always.
Can we use this information to know that the ratio between.
You're gonna get some
is
ratios going on.
-3 and 1?
You can. Anyone, before I show you what I would do, what I hope you do on Wednesday or Friday, does anyone have an idea of how to maybe express -3 besides this? I know there's other ways like -6/2. That's -3, that's even worse, but that's true. Does anyone think they have another way to express -3?
-3 radical 3/3, or radical 3?
Whoa, -3 radical 3 over radical 3?
No, that's not gonna work.
The other radical 3s you cancel, leave you a -3, that's true. Beautiful, and he wants me to change it. Chris, they got 3 over a -1. And I'd love to, as a student, I'd say something like that too, just like Eric and Chris. Guys, the highest this thing goes, which is sine, this y, is 1. Sine does not go any higher than 1. So I can't let it be a 3. So what is it, Professor? It's not a 3, what is it? And why would they give this? Maybe it's undefined, Professor.
Change it to 1 over -1/3.
Oh, now we're guessing.
Or -1 over 1/3.
We can start throwing fractions in and trying to come up with fractions and try to get a -3. Here's what I would do. I'm not gonna stand there and just look at that. I love what Chris said. Eric, you guys were thinking like I was thinking when I first saw this way back. My goodness, I know -3 is a -3/1, or a +3 over a -1. And then when you think about the sine, y, guys, this is the highest sine goes. 1, not 3. And the lowest is -1. You will never get a value lower than -1 for sine. Or one higher than 1 for sine. Okay, so I've got to be careful, I can't do it. Now what am I gonna do? Someone's going to help me. Let me see what type of a weekend you may have had. I don't think you spent too much time thinking about pre-calculus. That's my problem. We need to have a beach party. Yeah. I'll go to the beach and just, we're gonna do some math on the beach. Yeah, that's what we need. So we can relax a little bit at the same time do some math. Does anyone have an idea? This one's out of the way. This one's clearly done by something called an identity. I listed those properties for you. You say, oh no, Professor, more. Let me list them first, and then we'll go back and approach this using identities rather than just guessing. Guys, does anyone recall any of the other properties called identities that may help me later on? That's one right there.
Well,
I guess I had maybe 8 of those.
Science tan.
Nope. Okay, do it again.
well, yeah, sine squared plus cosine.
There's the
squared.
first one I love. Sine squared theta plus cosine squared theta.
And then 1.
Hang on now. And 1, we got that. That's accepted in all math textbooks. That's just a basic statement. It's always true. They call it an identity. Give me another identity.
1 plus cotangent squared is equal to cosecant squared.
Love it. We went through these last week. Guys were too interested in the Grammys last night. Now, what else?
1 plus tangent squared is equal to secant squared.
Very good. from that. You guys gotta know all these. Gotta know all these. Number 4. I think there were around 8 of these.
Cosecant theta is 1 over sine theta.
Beautiful. And this will help you as you move into that math 8. Give me another one.
Secant theta is 1 over cosine.
Beautiful. That's what my colleagues are saying students do not know, especially in math 8. They don't know the trig identities. Okay, I got 5 right now. Number 6, maybe that's it. Is it? Jonathan, you have all those listed right there?
Yeah,
Was there another one that maybe we're overlooking?
secant theta, cosecant, no, cotangent. We got the tangent theta. Are we missing that?
Okay, we got, the cotangent theta.
Well, cotangent theta is right there on the left, which is 1 over tan.
Academy thought it was 1 over tan, reciprocal.
But then there's also tangent theta, which,
Or cotangent theta, I think could be expressed another way.
Yeah, cosine.
There you go.
Over
sine theta.
Beautiful.
Yeah, oh, cotangent theta, I guess.
That's cotangent. Yeah, don't mix these up. I think now, guys, with all that, I think maybe that was it.
Here's tangent theta is equal to sine theta over cosine theta.
Oh my goodness. Thank you. And theta can be expressed as one of the most used ones, sine over cosine. Oh, there were 8. I thought for some reason there were 8. There were 8 of those. Now, my students are getting overwhelmed. They're saying, Professor, finally I sort of get a glimpse of the unit circle. I sort of see now the unit circle, what you've got to see. Now, besides the unit circle, I got to know this. Well, of course you do. And then besides this, we're going to see graphs. Then chapter 5 will be done. Now, hold on a second. Now, can anyone tell me without, you see right now, I hope the rationale why I can't use this, I wish we could, darn it. Eric, they go ahead and put a -3 here and a 1 here and be finished. But sine max or min is -1. Its max is 1. I wish I could do that, but I can't do it. So what am I going to do? I'll have written in my directions, show the identity being used for the way you got the answer. We're going to use one of the identities. We're not going to guess, we're going to use one of the identities. Now, does anyone have an idea which of these 8 might you turn to? Now, they gave you this. So you might want to turn to these 8 and find which one involves tangent, and at least it gives you a start. Guys, I know Eric was thinking about this one. That's how I got that -3 over 1, which does not work, so I'd stay away from that one. Is there another one that has tan in it that I might use? Because they gave me tan.
Yeah, the 1 plus tangent.
Yeah, the middle
The
one.
1 plus tan squared is equal to secant squared. Okay, here goes. You guys will call this number 1. 1 plus tan squared is equal to secant squared. They gave me tan, thank goodness, I can put that in, that's -3. Tan squared equals secant squared. Guys, do my math here, you're gonna get a 10.
Radical 10 isn't an option though, right?
Hang on. Then do a square root. Now right now, it's square root 10, it could be plus minus. Let me do this after I do my square root. I'm gonna put plus minus to play it safe, it can't be both. So now we have to decide, is it positive or is it negative? Radical 10, and I will place that with some thought, right there. Now, can anyone tell me which quadrant did we decide we were in at the very beginning? Quadrant 4. That's where they matched up. In quadrant 4, I think I pointed that out down there, positive, negative. And I'm looking at secant, and secant's definition is 1 over x. What is the x down there? Positive, so I'm placing +1 over another positive. does that ensure the answer is positive that I'm looking for secant? And it's positive, in this case, positive radical 10, not negative. All this thought that goes here. Now, Eric, I heard you. Heard you. You're saying, Professor, maybe I can't accept it because you said sine goes up to a 1.
I was wrong.
But this is not sine, this is secant.
You can, yeah, I was wrong.
And secant will go further, and we'll see why when we graph it. So that answer is okay. I'm gonna have Bart to check all these answers. Now, can someone tell me now, if that's established as radical 10, whoo, I gotta find others. Now what?
You can now find cosine.
Okay, cosine, I'm trying to find what relationship you're looking at here. Where was it? Where was it? Oh, they are reciprocals.
Yeah, so you just take 1 over radical 10.
Exactly, so
and then-
secant and cosine are reciprocals.
And then de-radicalize to
And
get.
right here, he says just flip this over.
Radical 10 over 10.
Okay, let's do this first. We 1 over first. Reciprocal. And then rationalize, end up with radical 10 over 10, some strange answers, there's the answer. Welcome. Now, does anyone see any of those trig identities, because you got to show which one you're using on the quiz or the exam. Another identity of the 8 that I could use somehow with what I have to find another missing part.
Can we use the first one to find sine?
Beautiful.
Sine squared plus cosine?
Here you go. He says, go to the first one, Professor, let's find sine. That's sine squared on the first one, plus cosine, well, I just found cosine. I can put this in. Now, it might be better just put it in as 1 over radical 10, it's up to you, or radical 10 over 10, because it's gotta be squared. So guys, it might be easier, since you got it squared, to think of like that. And that's supposed to be equal to 1 there. Okay, so guys, is that true? So I'm using that first identity. Yes or no? Now let's write this as, here we go, sine squared. If I square that, guys, that's 1/10. That's beautiful. Equals 1. Now what?
Subtract
By
1/10.
Now, move that 1/10 over. You're solving a trig equation now. Sine squared. Move that 1/10 over. I'll do it quickly. You're going to end up with 9/10. Then do what?
Square root.
Square root. So we end up with sine theta is equal to, now it looks like the top part's good, that's a 3. Radical 10 is not good, but I can't leave it. Can anyone tell me all the little thought in the algebra, what does that look like cleaned up?
Negative 3 radical 10 over 10.
Oh, you already put the negative sign there.
Oh, sorry, yeah.
3 radical 10 over 10, Eric?
Yeah, that's what but I did it through, finding 1 plus cotangent.
Oh, you could have. Hugo, good suggestion there. Now sine, I see a negative sign, he gave me a negative sign. I'm in quadrant 4, look at all this. Is the y short enough supposed to be negative in quadrant 4? And therefore sine should be negative? You gotta keep track of these signs here also. Wow, so I'm gonna take this back with his help. Hugo, it worked. This is the value. Now, does anyone see any other way to find, or something to find, the other 2 remaining ones?
Cosecant?
Well, you already have cotangent.
Oh, wait, cosecant. Could I use this relationship? They are reciprocals. And since I know what sine is, it may look a little strange. Go to sine and flip it over. And if I do flip it over, guys, it looks like this. 10 over a negative 3 radical 10. Boy, get some strange answers here.
Then rationalize.
Rationalize by multiplying by radical 10. Top and bottom by radical 10. So we end up with 10 radical 10 all over how much?
Negative.
Negative 30. I think it's negative 30.
Which will just,
And then kind of cancel a little bit and reduce it down. 10 and 30, what, 3? That's cute.
Radical 10 over.
Negative radical 10 over 3. UCLA is waiting for us. And keep in mind, guys, on the quiz or on the exam, you'll be placing whatever you chose here on the side of each one. You gotta show me what you were using, which identity. Now, there's only one value left, it's cotangent. Oh, I got right next to it.
-1/3.
Aren't they reciprocals? But if I'm cotangent, go back to tan, I hope you got tan correct. We had tan to be, oh, they gave it to me. This merely takes a reciprocal. What's a reciprocal of -3? Make it 1/3. And that's all they're saying to do, that's what this right here means. In fact, I had it right over here. Whew, do we now have all of them done?
Yeah.
Now, strangers like that, strange answers like that, I'd be scared, before I turn my quiz in, oh no, Professor Ramsey, sure enough, surely not, he would not give me a radical 10 or a radical craziness. Yes, I would. I would. Now, a few things you can do for a quick check. Chris, if I'm correct. If I square this one and square this one, sine squared plus cosine squared, and add them up, I better get 1. Go check, sine squared plus cosine squared should always be 1. Guys, if I square this, please someone tell me what is that squared?
Would it be 9?
9 times 10, 90 over 100.
Yeah, 9/10.
Is that 90 over 100? If I square this. If I square this one, I get 10 over 100.
Yeah.
With 90 over 100 plus 10 over 100, 100 over 100.
Oh.
If I look back and Jonathan's sitting there with tears in his eyes when he sees this on a quiz, he didn't get 1. He didn't get 1. And I look up at Chris and he's crying too. He got 2. I said, guys, what's wrong? You're supposed to get a 1. So sine squared plus cosine squared is equal to 1. Guys, I threw in probably one of the hardest ones to get you started with, where you have to use one of these. In other words, I can't use the unit circle. Darn it, I can't use the unit circle. Like I've been using every year on these.
Is secant squared plus cosecant squared
Oh,
also equal?
look at this, look at this. Lots of relationships here. For example, this should be true. Now, guys, we're standing and try it. 1 plus cotangent squared. That's 1 plus cotangent. We found to be that number. So it's 1 plus, if I square that's 1/9. That's what is 1 plus 1/9. What is 1? Here we go across the street. 1 plus 1/9. What is it?
11/9.
No, 1 plus 1/9, unless I'm.
Oh, 10/9.
10/9, 10 over 9. That should be equivalent to, where am I now? Watch me mess up here. That was cotangent, I did that. We squared it, that should be equal to cosecant squared. Where is cosecant in all this mess? Oh, here. If I square that, is that 10 over 9?
Yeah.
So you just grab those numbers, and Jonathan said, yeah, Professor, you can grab them. I'm having difficulty grabbing them. Mark says, Ramsey, you act like you know where these things came from. I don't know where they came from. Okay, so you gotta know your identities. Okay, look at it carefully. Yes, no? Now, you know you're doing 16 weeks of work in 6. If you're not feeling the effects, this is our, what, 5th week or 4th week? 5th week. This is our 5th week. If you're not feeling the aches and the pains like you went to the gym and worked out, if you're not feeling that by now, I don't think you've been doing your work. If you come in here looking all fresh, I would say, Burdock, you're looking way too fresh. You're not keeping up with all this. You should be worn out, bags are in your eyes, looking old. 10 years older. People on the outside are saying, man, you look old, you look horrible. What's wrong with you, Ramsey? Ramsey? And one of my students confided to me just recently, I'm not gonna tell you who it was. Did I tell you the story about the first day I met you guys? If your parents or your girlfriend or boyfriend or whatever starts seeing less of you, and you have to confront them and say, I've met someone. Hate to say it, but I've met someone. And sure enough, one of my students confided in me. And last semester, same thing, one confided in me. Yeah, I had to tell them, who'd you meet? Do I know them? They get all jealous and all that. No, I don't think you know. Who is it? Ramsey? Ramsey, you're not gonna see much of me. Not much of me. And if I look at you and say, yeah, your looks are changing too. You're looking older. Jeez, that math 2 class. Okay, guys, looking pretty good? Now, I gotta watch my time here. Here's a closing. I've got other things I'll do for a recap. Woo, here we go. Each one of these 6 trig functions, only 6 things, they have a graph. Now, when I graph them and show them like a graph, like a parabola, like a polynomial function had a graph. Those rational functions with the asymptotes, they had a graph. These things have a graph. And all of a sudden they're going to identify this as f of x equals sine x. F of x equals cosine x. They attach function to it. They want to know what that looks like. And when you see the graph, it may be for some students better to reflect to the graph than the unit circle. Okay, let me show you what's happening here, then we're going to take a break here. Please guys, don't get overwhelmed, but do keep up with your work. I'm here at 11:30 on Monday, Wednesdays, and Fridays. Park is here, Anna's here, the math lab is here. We're here. We're right here. And by the way, Ramsey is also going next week. Your final exam's on what, Thursday?
Yeah.
I'm going to do a special review session just for the final. And I'll let you know what times it is. I would expect full house. Okay, maybe on that, what, Wednesday before? Before that big knockout final exam, 3-hour exam takes place. And I'm going to ask Park to be with me so he could record this. Final exam review coming up. That's next Wednesday.
Professor, that final week, is it still going to be just review, or are we going to be learning?
Oh, no, whoa. No, Monday's new material, Tuesday's new material, Wednesday's new material. And then probably that, I don't know exactly how we'll do this, but we're gonna come up with a time to meet on Wednesday also, just for review. So we're gonna have new material. I wish we could just take the whole day for a review, I can't do that. Okay guys, let's do this. Eric, I'm thinking about you before I even graph this, something you gave us earlier. Here we go. And then we'll take you right up to break. We're supposed to take a break, what, 2 o'clock? Okay, real quickly. Part 1. Going through 1. Graphs of the 3 functions. Now, here we go. I gotta grab all 6. First one. Okay, now call this f of x. Make it a function. Sine x. To make it look more like what you're accustomed to as a function. Part. Okay, I'm gonna do just a rough sketch. I forgot my straight edge. Sine x. Guys, sine is y by definition. We all know that. And since I have limited time here before the break, let's reflect back to what the unit circle, again, looks like. Major points, 0, 1, 0. Pi root 2, 0, 1. Pi, -1, 0. 3 pi root 2, 0, -1. Let's step back and make sure all those are labeled correctly. We all know those. Those are just basic ones. Now, what I'd like to do on the side here is this. Go to a grid. Watch carefully. I like the method. Coming up. On the grid, I'm gonna go through the unit circle. Like I said, I use the word unwrap. I'm gonna take my angles, they're in radians, also could represent 2 pi. One complete revolution, we all know that. I'm gonna take those in the blue and place them on the x-axis on the grid, like this. 0 to begin, pi over 2, little space, pi, 3 pi over 2, 2 pi. Those are on the x-axis. Take it directly from the unit circle. On the y-axis, here we go, guys. What do I want to do? I'll see with my points here. This is y, this is x. Okay, y and x. What's the highest y you see here?
1.
Okay, so on the y-axis, I'm gonna go up to a 1, but this will be max. And what's the lowest, if you search those, lowest y value?
Negative one.
Negative 1 on the y. Right there. Now to graph sine x, which is the y. I'm just looking at the y coordinates. The grid is set up. Now, at 0, right here, the y coordinate is also 0. So it says my graph for sine starts right here. When I reach pi over 2, I'm looking at y, the y, sine, it's 1. It goes up to 1. At pi over 2 is 5 points. At pi, which is over here, the y coordinate is 0. That's sine. I'm back at 0. 3 pi over 2, here, the y value, which is sine, is negative 1. It drops down to a negative 1 here. 2 pi all the way around, one complete revolution takes me back to here, my starting place, where the y coordinate again is 0. Now, if you connect those points, now we'll use like a curve. This one looks something like this. There's one cycle of the sine function graph for you. I made little arcs because this came from the circle. The circle has arcs. So it has arcs there, guys. I hope you can see that in orange. Beautiful. That's one cycle. Could I, if I wish, after the break, could I now maybe say, oh, I want another cycle? Could this thing go around again? If I wish? And I could draw maybe another cycle. I'm not going to do it until after the break. In other words, could it may go up and do this again if I make 2 complete revolutions? Could I do something like that again?
Yeah.
Could I do this forever?
Yes.
Could I do it on the left?
Yes.
Could I do it backwards? I'll look at my unit circle and do something like that. And continue it. It goes forever. So the one cycle I want you guys to be responsible for is that one in the dark, the very first one I put on there. Let that be sort of like the paragraph. That's the way sine looks. Now, Leo, before we take a break. And Eric. Let's really think about Eric here. Eric, class, this is sine. This in the orange represents the function, as is the vertical line test, sine x. Please tell me the values of sine is caught between.
Like the range or the
Yeah, the range, thank you, the range.
negative 1 and 1.
The range is
We'll
caught
bracket negative 1.
negative 1 to 1, and there are brackets. So you're caught between negative 1 to 1 for the range. That's why when Eric gave me that suggestion earlier, I couldn't accept it. The lowest the sine function goes is negative 1. That's the lowest for the parent graph. And the highest is 1 for the parent graph. Now, if you put a 2 out here, make this 2 sine x, that's going to be a vertical stretch. That's a different graph. You want to stretch this graph. John, before we take a break, if I say sine and I put maybe x minus pi, that means x minus pi in parentheses, that might be a horizontal shift to the right.
Yep.
We're going to be doing transformations on this parent graph. Here's the parent. Okay, by the way, guys, the domain, the range of that domain, now there was the domain of the entire function. Look right like this. I just have one cycle.
All real numbers.
Thank you. Right like this. All real numbers. That's right. forever. From left to right. But the highest, lowest is -1 to 1. It's amazing for the sine graph. Before I leave, anyone tell me real quickly, which I think is better to see on this graph than the unit circle. In which quadrants is sine positive? Based on this graph?
Quadrant 4.
Well, this is quadrant 1, look at that, that's quadrant 1 right there. This thing has the quadrants on it. This is quadrant 1, this is quadrant 2. Is it? Is my graph above the x-axis in both those quadrants? Here's quadrant 1, quadrant 2, this represents quadrant 3, this is quadrant 4. Is my orange graph above the x-axis in quadrants 1 and 2?
Yeah.
That's where sine is positive. And you go through and find where sine is negative. But just looking at the above the x-axis, below the x-axis. Making sense, guys? That was not enthusiastic. Okay. Okay, guys, take a well-deserved 15-minute break.